यहाँ से बताना मेरे को। क्या किया? स्किप एड
जाइए अपना पीछे स्क्रीन पे काम करना शुरू।
इस पे
हो गया लाइव।
आ रहा है। 10 सेकंड हो रहा है।
वो भी हम लोग पहले ही आ गए।
So, hello everyone, welcome to Ekeeda, and today we will study. Today we will study a new topic and very important, you can say. Our topic today is inventory control. Okay, our topic is inventory control. Okay, very important from GATE point of view. Okay, so each and every year, okay, you can expect at least one question. At least one question you can expect from this topic. Okay, minimum one question I am telling. More than two questions. This year also, GATE 2020 also, questions were asked in both the sets of 2 marks each. Okay, so important from the examination point of view. Now, so the question is, what is inventory? Okay, what is inventory? So I have already written the definition. It says that inventory can be defined as stock in hand. Okay, stock in hand in order to meet the future sales or demand of a product. Okay, so it is something that we keep the units or anything in stock so that the future sale of the product can be made. Okay, it can be anything. It can be automobile. Okay, it can be automobile or any other units. Okay, so to meet the future sales, we keep the inventory in hand. Okay, in this month, this is known as festival season. Okay, festival seasons. Okay, we see that in festival seasons the sales of the automobiles increases. So in order to meet the demand of the customer, we used to keep the stocks in our hand so that the customer does not go back. Okay, so this is inventory. Okay, keeping something in stock for future sale. So inventory has 4 types of cost. Okay, 4 different types of cost. 4 types of cost, you can say, it is involved in inventory. Okay, very important. The whole chapter, you can say the whole chapter is based on types of cost. Okay, here I have written types of cost in inventory model. So the whole chapter of this inventory is based on this cost. Okay, so the first one is purchase cost, the second one is ordering cost, the third one is holding cost, and the last one is shortage cost. Okay, so from the name only, the first one is purchase cost. Okay, purchase cost is defined as annual demand into cost per unit. Okay, so the annual demand, okay, the annual demand is denoted by capital D. Okay, it says that quantity. Okay, annual demand means units per annum. Okay, annual demand is basically, it is in units, you can say in units it is said. Okay, for example, you have 10,000 of units, you can say 10,000 of units. So for annual demand we use the letter capital D. Okay, and this C means, C is defined as cost per unit. Okay, cost of one pen is 10 rupees. Okay, so this C means cost per unit. Okay, so number of units into cost per units, you can say number of units, you can see here capital D, number of units into cost per unit will give you the purchase cost. Okay. Next cost is our ordering cost. The second one is ordering cost. Okay. The second cost is ordering cost. So ordering cost is defined as number of orders into cost per order. So number of orders it is denoted by capital N, and cost per order it is denoted by C naught. It is denoted by C naught. Capital N number of orders it is written as N equals to D by Q. Okay. Number of orders or capital N it is denoted by N equals to D by Q. Here I have written N equals to D by Q, where D is the annual demand. Okay, where D is the annual demand. These things only. Okay, D is the annual demand. And what is this Q? Q is the quantity. Okay, Q is the quantity per order. So this Q is the quantity. It is the quantity per order. Okay, it is the quantity per order. So it may be in one order you are ordering 100. Okay, in the other orders you are ordering 200. In the other order, in the third order you are ordering 500 units. So it is quantity per order. Okay, it is quantity per order. That is our Q. Okay, Q is quantity per order, and the quantity can be of anything. Okay, any units. Okay, any units it can be there. C naught is the cost per order. This C naught is the cost per order. Okay, so if you are ordering, suppose if you are ordering 100 units, if your quantity is 100 units per order, then C naught is the cost of these 100 units. If you are going to order 200 units per order, then C naught will be the cost of these 200 units. If you are going to order 500 units, then this C naught is going to be the cost of these 500 units. Okay, so basically I'm telling that this C naught does not depends on number of units. Okay, here you can see this C. Okay, this C is cost per unit. Okay, it is the cost of single item. Okay, this is the cost per unit, but here it is not per unit, it is per order, and in a order any quantity can be possible. Okay, in a single order any quantity can be possible. It can be 100, 200, 1000, 10,000. Okay, it can be anything. Okay, so this C naught does not depend on the per unit, it depends on per order. now now our now the examples of ordering cost. Okay, it is the cost of changing an order. Okay, ordering cost can be written in terms of cost of changing an order. Okay, transportation cost is included in ordering cost only. Communication cost, it is also included in the ordering cost only. Okay, so everything comes under ordering cost. In the examination, there may be written the communication cost. Okay, in the examination, suppose it is written that the communication cost is 100. So it means it is written 100 per orders. Okay, it is written 100 per order. So it means that it is just like ordering cost. Okay, it is C naught. It means C naught is given. Okay, and the next one is setup cost. Okay, setup cost, generally in books setup cost is given in a different topic, but setup cost is just like ordering cost. Here only the difference is that we are not going to order from outside. Okay, in setup cost we do not order from outside. Okay, we do not order from outside. Okay, we are going to produce the units in our plant only. So setup cost basically means that it is the cost it is the cost associated with it is the cost associated with bringing a it is the cost associated with bringing a shutdown plant bringing a shutdown plant into running condition. Okay, so setup cost means there is a shutdown plant and you are going to bring it into a running condition. So the cost included to bring the shutdown plant into running condition is known as setup cost. Okay, so setup cost is just like ordering cost, only when setup cost will be given, then it will be given as like setup cost means you can write number of setups, number of setup into cost per setup. Okay, number of setup into cost per setup. And in the ordering cost, what was there? It was number of orders into cost per orders. So the difference is nothing. Okay, you can treat this as just like ordering cost. Okay, so you can treat the setup cost just like the ordering cost. Only the difference is that we do not order from anything. We do not order anything from the outside. Okay, we just produce everything in our plant. Okay, so the cost of arranging the labors, cost of arranging the machines, okay, everything will be under setup cost only. Okay, so it is just like the ordering cost. Only the difference is that it is number of setup into cost per setup, and in ordering cost it is number of orders into cost per order. Okay, so just like ordering cost, we have got setup cost. Okay, now our third cost is holding cost. Okay, our third cost is holding cost. So holding cost, from the name only it is clear that what do you mean by holding. Okay, holding just like rent. Okay, you can say just like rent. You are going to pay the rent for keeping the items or keeping the units or keeping the inventory. Okay, so the holding cost is defined as average inventory into holding cost per unit per year. Okay, so why average inventory? Average inventory, okay, this q, what was this q? Q was quantity per order. Okay, this Q was quantity per order, and this Q is also known as inventory. Okay, this Q is also known as inventory. Inventory means units. Okay, units or any quantity. So this Q is also known as quantity, or it is also known as inventory. So holding cost is defined as average inventory. So if Q is inventory, then average will be average inventory will be Q by 2. Okay, so why q by 2? Because suppose you have q units with you. Okay, you have q units with you, you have ordered q units. Okay, so some q will be supplied to the customer and some q you will be keeping for the future. Okay, you have ordered this q, so some is supplied to the customer at that time only, and some amount of q will be kept, okay, for the future sale. So we assume that this q by 2 it is supplied, this q by 2 it is supplied directly, and this q by 2, okay, this q by 2 is for, it is for future. Okay, it is for future sale, you can say. That's why we are going to define it in terms of average. Okay, and this ch, okay, this ch is holding cost per unit per year. Okay, so one thing you have to keep in mind that if you are going to put D, capital D, if you are going to put capital D, what was capital D? It was annual demand, you can say. This capital D was annual demand. Okay, so if the demand is in terms of year, okay, if the demand is in terms of per annum or per year, then this ch unit of this ch is also going to be in years. Okay, the unit of this ch is also going to be in year. When we will solve the numericals, then the concept will be more clear to you. But now you can remember it like this, that if capital D is in annual, that is in year, then this ch unit is also going to be in year. So you have to see the data of the numericals. Okay, so this is holding cost, average inventory into cost per unit per year, that is ch, and it includes the cost of maintaining the goods. Okay, it includes the cost of maintaining the goods. It also includes the damage and depreciation cost. Okay, it also includes the damage and depreciation cost, because if you are going to keep the things for future sale, okay, if you are going to keep the things for future sale, then the items may get damaged, or you have to maintain the item. So for that maintenance, or for that holding, you can say, you will have to pay the amount. So everything, maintenance and damage and depreciation cost, will fall under the category of this holding cost. Okay, now now holding cost, here I have written that holding cost equals to X percent. Okay, holding cost equals to X percent. Okay, so in the examination, sometimes they give like this. Okay, in the examination, sometimes they give us the data like this, that ch is 2%. Okay, ch is 2%, and c was cost per unit. Okay, this was unit cost, and c is rupees 10 per unit. Okay, so what you have to do, you have to find the ch. So ch is going to be 2% of, ch is going to be 2% of c. Okay, that is 2 by 100 into 10. Okay, 2 by 100 into 10, that is 0.2 per unit per year. Okay, so whenever you will find this type of problem, that ch is written in terms of percentage, so ch is always going to be X percent of C here. If holding cost is given in percentage, then convert it into X percent of unit cost. Okay, this is C. C means cost per unit. So why it is like this? Why it is like this? Because whenever, suppose you have two things. Okay, the first thing is, suppose you have two things. The first thing is onion, and the second one you have diamond. Okay, you have two things. The first items you are ordering is onion, and the second items you are ordering is diamond. Okay, so for onion you are going to spend less unit cost. That is, suppose the unit cost of a single onion is rupees 20 per unit. Okay, but for diamond, the value of C, that is cost per unit, it is going to be more. So let it be 20,000. Okay, 20,000 per unit. Okay, so now for holding the onion, you are going to pay less amount of ch. Okay, why? Because you are going to pay less maintenance cost. Okay, but for diamond the ch value will be more. Okay, you are going to pay more amount. Okay, because it is expensive, and you are going to pay the more maintenance cost. Okay, more security cost. Okay, because it is more expensive item. Okay, since it is more expensive item, so you are going to pay more and more holding cost here. Okay, the ch value is going to be more, and this is a less expensive item. That's why you are going to pay the value of ch, that is less. Okay, you are going to pay a less holding cost for the onion, but you are going to pay the more holding cost for the onion. Why? Because it is more expensive. More expensive means, see here, the cost per unit is more. Here the cost per unit is less. That's why ch is always expressed in terms of percentage of unit cost. Okay, because more the unit cost, more will be the ch. Lesser the unit cost, lesser will be the ch. Okay, if the item is more expensive, you are going to pay more and more maintenance cost. And if the item is less expensive, items mean inventory, you can say, if the inventory is less expensive, then you are going to pay less holding cost. Okay, that's why ch is always some percent of the unit cost. Okay, now the last cost is shortage. Okay, shortage cost. Now the last cost is shortage cost. The last cost we have got is shortage cost here. Okay, so shortage cost is also defined just like the holding cost. It is defined as average shortage into cost per unit per year. Okay, here also we deal in units per year. So shortage, capital S, is defined as the shortage quantity. Shortage quantity. So average shortage is SY2. So SY2 is defined in terms of average shortage. Okay, why average? Because every time the shortage is not going to happen for each and every customer. Okay, the shortage is going to occur only for few of the customer. That's why we deal in terms of average shortage here. Okay, and CS. Okay, you can see CS. CS is shortage cost per unit per year, you can say. Okay, this is defined as shortage cost. Okay, this is the shortage cost per unit per year, just like CS was the holding cost per unit per year, and CS is the shortage cost per unit per year. Okay, so it includes cost associated with no sale of product. Okay, shortage cost means the cost associated with no sale of the product. It means that the product has not been sold. Why? Because there was a shortage of the quantity. That's why the product was not sold. Okay, the profit which was going to come, it is not coming. Why? Because you have the shortage of the items. Okay, you have the shortage of the items. That's why there is no sale of the product. And the second one is cost associated with loss of goodwill of the customer. Okay, cost associated with loss of goodwill of the customer. It means that suppose there is a shop. Okay, there is a shop, and daily you are going to the customer. Okay, you are going to the customer and asking for some items. Okay, you are going to the customer and asking for some items, but the customer says that there is a shortage. Okay, the customer says that there is a shortage, and he tells you that I am going to get this item from another shop for you. Okay, the customer says that this item is not available with me, but I will arrange the items from somewhere else for you. You said okay. Again you went. Okay, you went. It was the first time. Again you went there, and again he says the same thing, that again there is a shortage of the items, and he will provide the items to you from somewhere else. It means that the third time you will not go to that shopkeeper. Okay, because you know that again he will say there is a shortage, you will go to some other shops. Okay, you will go to some other shops. It means the profit which was going to come, okay, the third time the profit which was going to come, it is not coming this time. It means there is a loss of goodwill of the customer. Okay, so loss of goodwill of the customer means that the third time you are not going to that shopkeeper for buying the products, because every time he has the shortage of those items. Okay, and sometimes there is intentional shortage. Okay, sometimes there is intentional shortage is there, because the cost of holding the items becomes more. Okay, sometimes I'm writing it. Sometimes you can say intentional shortage is allowed. Sometimes intentional shortage is allowed. Okay, because cost of holding becomes greater. Okay, cost of holding becomes greater. That's why the customer allows the shortage. Okay, so sometimes intentional shortage is allowed, but the shortage allowed is of low cost items only. Okay, so intentional shortage is allowed for low cost items only, you can say. Intentional shortage is allowed for low cost products only. Okay, because the cost of holding is more than the profit. Okay, the customer thinks that the cost of holding is going to be more than the profit, so he allows the intentional shortage for the low cost product. If he is going to allow the shortage for a higher cost product, it means he will get a loss. Okay, the profit which he was going to get, he will not get. So the cost shortage is allowed only for a low cost item. For examples, you can say milk. Okay, milk packets. Okay, many times you must have encountered it, that whenever you are going to a shopkeeper, he says that he do not have the milk packets with him, everything has been finished, because there is intentional shortage, because he knows that the cost of holding the milk packets for the next day is going to give him the loss. Okay, so that's why he allows here the intentional shortage, so it is only for a low cost products. Now, for each of the gate preparing student, okay, each one of the gate preparing student, you can buy the subscription. Okay, gate subscription, I'm changing the color. You can buy the gate subscription. You can buy the gate subscription of Ekeeda. Okay, Ekeeda. Okay, you can buy the gate subscription of Ekeeda. And if you are going to use the code Gaurav 10, okay, if you are going to use the code Gaurav 10, then okay, this is the code. Okay, if you want the gate subscription of Ekeeda, then just use this code Gaurav 10. You will get a 10% discount. Okay, you will get a 10% discount on your course. Okay, so very experienced faculty you will be meeting with. Okay, so they will give you different tips and tricks to clear the exam. Okay, so for any branches, okay, for any branches, you can use this code, that is Gaurav 10. So by using this code, you will get a 10% discount on gate subscription batches. Okay, so just use this code. If you want the course, just use the course, use this code, you will get a 10% discount. Okay, now, so this was the 4 different types of cost. You need to remember the formulas of each cost. Okay, now our next term is total annual cost, that is TAC. Okay, the next term is total annual cost, that is TAC. So I have written is that total annual cost, it is the summation of purchase cost plus order cost plus holding cost. Okay, shortage cost is not there. Okay, obviously there is clear indication that we are not going to include here shortage cost. Okay, so the total annual cost of any item, it is going to be the summation of purchase cost, ordering cost and holding cost. So what was the purchase cost? If you are going to write TAC, so the purchase cost was, it was the product of capital D into C. So capital D was the annual demand and this C was the cost per unit, plus what is OC? OC is the ordering cost. Ordering cost was the number of orders, that was D by Q, annual demand divided by quantity per order into C naught. C naught is the cost per order, plus what is the holding cost? Holding cost, it is the average inventory, that is Q by 2 into cost per unit per year, that is CH. Okay, so the summation of purchase cost, ordering cost and holding cost is going to give you the total annual cost. Okay, now you can see that this purchase cost, okay, D into C, it is independent of, okay, this purchase cost, we can write here, this purchase cost is not a function of this quantity, that is Q. Okay, what was Q? Q was the quantity per order. So this purchase cost is basically independent of this Q because it is going to depend on per unit. It does not depend on per order. So this purchase cost is independent of Q, but the ordering cost and holding cost, both are the functions of Q. Okay, ordering cost and holding cost, both are the functions of Q. Okay, so if you are going to change the amount of Q, if you are going to change the amount of Q, OC and HC both will be changing. Okay, if you are going to change the amount of Q, ordering cost and holding cost both will change. So now that's why our next term is total inventory cost. Okay, our next term is total inventory cost. In short, it is also known as TIC. Okay, it is also known as TIC. So what is inventory? Inventory means Q. Okay, I have told you inventory. Inventory means Q. Okay, so here we have seen that ordering cost and holding cost is a function of inventory. That's why total inventory cost, it is a summation of ordering cost and holding cost only. We are not going to include purchase cost here because purchase cost is not the function of Q. Okay, so if you are going to write that this TIC, total inventory cost, so it is the summation of ordering cost, that is D by Q, number of orders into cost per orders plus average inventory, that is Q by 2 into CH. Okay, okay, because both are function of Q only. Now, now one question is there that how much quantity to order. Okay, how much quantity to order. So you think that we should order more and more. Okay, we should order more and more Q because for 100 Q also you are going to pay C naught amount. For 1000 Q also you are going to pay the same amount. So why not to order more and more Q? Okay, so if you are going to order more Q, okay, if you are going to increase the quantity of Q, it means the ordering cost is going to decrease. Okay, if you are going to increase the value of Q, if you are going to increase the value of Q, see here, ordering cost. Okay, ordering cost is inversely related to Q. So if you are going to increase the quantity, ordering cost is going to decrease, so it will be beneficial for you. Okay, it means that you are going to order more and more number of units, but you are going to pay a lesser ordering cost. But the problem is there that if the value of Q increases, if the value of Q increases here, holding cost is directly related. Okay, it is directly proportional to Q. Okay, so if you are going to pay more and more Q, your holding cost, okay, your holding cost is going to increase. It means you are going to pay more and more holding cost. You have to provide more and more maintenance cost. You have to provide more and more rent. Okay, so what quantity to order? Okay, what quantity to order so that we can order an optimum Q. Okay, if you are going to increase the Q, ordering cost decreases but holding cost increases. And if you are going to decrease the Q, okay, so one thing will come in your mind, that does decrease the order. So if you are going to decrease Q, now the ordering cost will increase. Okay, you will have to pay more and more ordering cost, although the holding cost will decrease. Okay, if you are going to decrease the value of Q, holding cost will decrease, but the ordering cost is going to increase. Okay, so you must order the optimum quantity. You must order the optimum quantity. So how to get the optimum quantity? How to get the optimum quantity? So there are two methods. The first method is analytical method. The first method is analytical method. Okay, it says that this TIC is the function of Q, D by Q into C naught plus Q by 2 into CH. Okay, and you have to order the optimum. So what you are going to do? You are just going to differentiate this TIC, okay, because it is the function of Q and Q is the variable here. Okay, so just you are going to differentiate this total inventory cost with respect to Q. So what you will get? See here, TIC is just like 1 by x. Okay, this x is here variable. Okay, this x is here variable. Everything is constant. So you will get 1 by x. Differentiation of 1 by x is minus 1 upon x square. So it will be minus d upon q square into c naught. And here it is just like x. So differentiation of x you are going to get 1. Okay, so you will get 1 by 2 into ch. So what we will do, we will just put it 0. Okay, we will just put it 0 and we will solve for the value of q. Okay, you are going to solve for q. So from here the value of q you will get it as under root of 2 d c naught by ch. Okay, 2 d c naught by ch. Okay, so this q is the known as optimum order quantity or economic order quantity. This q is known as economic order quantity. Okay, this q is known as economic order quantity. In simple, it is also known as EOQ. Okay, and now this q is since economic or you can say optimum. Okay, economic order quantity or you can say optimum order quantity. So this q now becomes q star. Okay, now this q becomes q star. Okay, here this q becomes q star and this q star is economic order quantity. So you must order q star to establish a balance between ordering cost and holding cost. Okay, you must establish a balance between ordering and holding cost, and for that you must order this EOQ. Okay, and the EOQ formula is very important. Okay, throughout this inventory chapter you will encounter this formula. Okay, under root of 2 d c naught by ch. Okay, so this is one of the method that is known as analytical method. Now the second method is graphical method. From the graphical method also you can find this formula. The second method is graphical method. Okay, so what I am going to do, I'm going to draw a graph. Okay, I'm going to draw a graph between cost. On y-axis we have kept cost and on x-axis we have kept quantity. Okay, so a graph between cost and quantity has been drawn. Okay, so just see here, if you are going to increase the value of q, okay, if you are going to increase the value of q, that is quantity, your ordering cost will decrease. Okay, so if you are going to plot the graph of OC, so it will decrease, means it is like this. Okay, and by increasing the value of q, okay, just by increasing the value of quantity, your holding cost is going to increase. So the holding cost will increase. Okay, so this graph represents holding cost and this graph represents ordering cost. Okay, so we must reach at the optimum. Okay, here see the point where both the curves cut each other. Okay, the points where both the curves cut each other is known as the optimum order quantity. Okay, so our new graph will be like this. Our new graph is like this, and this graph, green color, it is TIC. It is known as total inventory cost, and it is the minimum. Okay, it is the minimum. Okay, this is the TIC curve, and this cost is the, you can say, minimum cost. Okay, this cost is the minimum cost, and the quantity where we are getting the minimum cost. Okay, the quantity where we are getting the minimum cost, that quantity is known as EOQ quantity, that is q star. Okay, The quantity where we are going to get the minimum cost, that quantity is known as EOQ, that is Q star. Okay. So what should be the cost? Okay, what should be the cost? So first we will not talk about the cost. Okay. First we will see that what should be the quantity. So we can write here that from the graph, ordering cost and holding cost becomes equal. Okay, both are cutting at the same point. It means both the costs are equal. So ordering cost is D by Q into C naught, and this is Q by 2 into CH. Okay, so from here just solve the value of Q. Okay, so what you will get? You will get Q equals to under root of 2D C naught by CH. And now, since it is the optimum, this Q becomes Q star. Again, the same formula, very important formula. Okay, I'm telling it, very important formula from the examination point of view. And now, at this Q star, okay, at this Q star, what should be the cost? Okay, from the graph, we have seen that this is the, at Q star, we are going to get the minimum cost. So we can say that at EOQ, our inventory cost, that is total inventory cost, TIC, at EOQ, this cost becomes minimum. That's why we are denoting it with TIC star. TIC star means minimum inventory cost. Okay, this TIC star means minimum inventory cost. So at this TIC star, what we have got? We have got holding cost plus ordering cost. Okay, TIC means ordering cost plus holding cost. Okay, because both are the function of Q only, and here both becomes equal. Okay, so we can write it, this holding cost we can replace with this ordering cost, we can replace with the holding cost. So it will become twice of holding cost. Okay, it will become twice of holding cost. Now 2 into holding cost. So what is the holding cost? Holding cost is average inventory into, that is average inventory was Q by 2 into cost per unit per year. Okay, and at EOQ, okay, we are talking at EOQ. At EOQ, what is this Q? Q is the Q star. Okay, so just put the value of Q star from here. Okay, just put the value of Q star from here. This 2 and this 2 will get cancelled, and we will get our TIC star. We will get our TIC star at under root of 2D C naught into CH. Okay, we will get the value of this TIC star at under root of 2D C naught into CH. And very important also, okay, these both the formulas are very important. We will encounter both the formula throughout this chapter. Okay, so you must remember this EOQ quantity formula, that is under root of 2D C naught by CH, and TIC star formula root 2D C naught into CH. Okay, this TIC star is the minimum inventory cost, which we are going to get at this optimum order quantity. Okay, okay, at optimum order or economic order quantity, the inventory cost is going to be minimum. Otherwise, at one time the ordering cost was increasing and holding cost was decreasing, and at the other time the ordering cost was decreasing and holding cost was increasing. So to establish the balance between both the cost, we have found this EOQ quantity, and we have found this minimum inventory cost. Okay, sorry. Now we will talk about the inventory models. Okay, so the first classification is based on the basis of lead time and demand rate. Okay, so demand rate, you know, okay, it can be quantity per day or quantity per year. Okay, and lead time we will talk. Okay, we will talk about lead time, that what is this lead time. Okay, so on the basis of lead time and demand rate, the inventory model is classified into two types. The first one is deterministic model, and the second one is probabilistic model. Okay, The first one is deterministic model and the second one is probabilistic model. So deterministic model means here the lead time and demand rate is constant. Lead time and demand rate is constant. Okay, so in this type of model, the lead time and demand rate remains the constant. But in probabilistic model, the lead time and demand rate is fluctuating, you can say. Okay, fluctuating throughout the year. Okay, so two types of model are there: deterministic. In deterministic, the demand rate is constant. Okay, in each and every month you are going to get the same demand data from the customer. But in case of probabilistic approach or probabilistic model, the demand rate is fluctuating. Okay, so basically the probabilistic model relates to the practical conditions. Okay, in practical condition or in practical world, obviously the demand rate does not remain the constant. Okay, so here the demand rate fluctuates. Okay, so basically these are used for items like, okay, probabilistic model, fruits, okay, flowers, vegetables, you can say. So for each of the items, the demand rate fluctuates. It is not going to remain the constant. Okay, so both model we have to study. The first one is deterministic and the second one is probabilistic. Thanks, Aditya Raj. Now, the deterministic model is classified into four different categories. Okay, the first one is EOQ model. Okay, the first one is EOQ model. It is also known as infinite replenishment model or Harris-Wilson model. Okay, three names. All the three you must remember. Okay, so in deterministic model we have got four different types. Okay, four types model. So first one is EOQ model, Harris-Wilson model or infinite replenishment model. Okay, the second one is price break model or discount model. The third one is production consumption model, and the fourth one is shortage model. Okay, so we will talk about each and every of the model in detail in this lecture also and in upcoming lectures also. Okay, so the first model is EOQ model. Our first model is EOQ model. Our first model is EOQ model. So formula we have already derived. Okay, the formula we have derived early. The first model is EOQ model. The other names also you must remember. Okay, so in EOQ model, I'm going to draw a graph between quantity and time. Okay, and here it comes under deterministic approach. Okay, so deterministic, you know that the demand rate is constant. Okay, so the graph is between quantity and time. So suppose we have the maximum inventory with us. Okay, here this green color represents the maximum inventory, that is Q. Okay, Q is our the maximum inventory here. Okay, so suppose we have got the maximum inventory here, and as the customer demands the items, we are going to supply, and the supply is and the demand is of constant. Okay, so the constant, as the demand comes, the quantity Q will decrease. Okay, its value is going to decrease, so the graph will come like this here, and at a time there will be a time when the quantity is going to be finished. Okay, now the other name was infinite replenishment. Okay, the other name was infinite replenishment. It means that whenever you see that the quantity is going to decrease and at a certain time it is going to become zero. Okay, So let the demand rate be small d. Okay, the small d represents the demand rate. Okay, the small d represents the demand rate. Okay, it is not annual. Okay, annual was denoted by capital D. Small d can be in terms of days or in terms of weeks. Okay, according to the question we will determine. So this small d is the demand rate, q is the maximum inventory. So when you will find that the inventory is going to be zero, so at a certain point you are going to reorder. Okay, you are going to reorder. Okay, so suppose this line represents the reorder point. Sorry, this line represents the reorder point or reorder level. Okay, so at this point ROL, okay, in short ROL, reorder level, or ROP, reorder point. So at this point you are going to reorder the maximum inventory, that is such that when you will reach here you should not feel the shortage. Okay, when you will reach here you will get the maximum because you have reordered the quantity. So you will just reach here. Okay, you will just reach here, and again the graph will be like this. Okay, for the next period the graph will again come like this. Again you are going to reorder it. Okay, so again you will reach here at the maximum inventory. So in this way the graph will move. Okay, in this way the graph is going to move. Okay, like this. In this way the graph is going to move continuously. Okay, so this point, this capital T, this time period is denoted by capital T. Okay, this capital T is known as the length of one inventory cycle. Okay, this capital T is known as length of one inventory cycle. Okay, and this reorder point. Okay, here you can see we have reordered the quantity here. So this time, this small time is known as lead time, represented by LT. Okay, this LT. Okay, this LT is our lead time. So how we are going to define it? Capital T. Capital T, it is the time period within which the maximum inventory is consumed. Okay, we can define it like this. Time within which the maximum inventory is consumed. Okay, because you can see here when it was capital T. Okay, when it was capital T, our inventory becomes zero. Okay, although it is not zero because we have reordered it, but in the practical condition it must have become zero because we have consumed each and every inventory. Okay, the each and every inventory has been consumed by the customer. So time within which the maximum inventory will be consumed. And what is the lead time? LT. LT we can define, it is the time period within which the reordered quantity will be consumed, or you can say that it is the time period between placing a fresh order and getting the previous inventory consumed. Okay, here at this point you are placing the fresh order. Okay, and here you are consuming the previous inventory. So the lead time can be defined LT. Okay, LT can be defined as time between placing a fresh order and getting the previous inventory consumed. Okay, so this is the lead time. सर जा रहा है मैच देखने, रिकॉर्ड कर दीजिएगा। ओके, सो from this graph we can derive some formula. You can see, okay, we can write this capital Q. Okay, this capital Q can be written like this. Capital Q can be written D into small t. Okay, this D is, small d is the demand rate. Okay, number of units per day you can say, and this T is the time. Okay, capital T is the time period. So this Q can be written in terms of capital small d into capital T, where this small d is the demand rate. And in a similar way, reorder ROL, reorder level can be also written as like this. Reorder, here the small triangle you can see. Okay, the small triangle you can see. We can also do the similarity of triangle. Okay, we can also follow the similarity of the triangle, but directly I'm going to write this reorder level. Okay, this line. Okay, this ROL can be written in terms of small d into LT. Okay, this is reorder level or reorder point. So these two formula are very important. Okay, you can achieve it from the similarity of triangle also. Okay, you can achieve it from the similarity of triangle also. So this ROL is a small d into T. This is a small triangle. Okay, this is a small triangle from the graph, and from the capital triangle. Okay, you can write capital Q equals to small d into capital T. Okay, now we have got one question. Okay, in the upcoming lecture also we will talk about inventory only. Okay, so don't worry, we will complete our inventory chapter, but here we have got one question, very simple one. Here see, it is written that if TIC means total inventory cost at 600 units and 1200 units are equal, then find the EOQ. So basically they have told that the TIC at 600 units, it is equals to TIC at 1200 units. Okay, so this condition has been given in the question. Okay, from the statement, TIC at 600 units is equals to TIC at 1200 units. So they are asking that what is the EOQ? Okay, what is the EOQ? The formula of EOQ is, you know, root 2D C naught by CH. So we will go from the basics only. Okay, so what is this TIC? TIC was the sum of ordering cost plus holding cost. Okay, TIC was the summation of ordering cost plus holding cost. So what was the ordering cost? Ordering cost was, D by Q into C naught plus Q by 2 into CH. And what is this Q? It is at 600, equals to the same formula, D by Q into C naught plus Q by 2 into CH at 1200. Okay, now just put the values. D by 600 into C naught plus 600 by 200 into CH equals to D by 1200 into C naught plus 1200 by 2 into CH. So what we should do? We should bring the similar quantity on a single side, and here C naught and here also C naught. So what we will do? We will bring this C naught to this side and we will bring this CH to this side. So D into C naught is constant, and we will get here 1 by 600 minus 1 by 1200. Okay, bringing this quantity here, and here we will get 600 minus 300. Okay, into CH. Now solve it. Now solve it. So we will get here, what we are going to get? We are going to get D into C naught by 1200. 1 by 600 minus 1 by 1200, we will get 1 by 1200, and here we will get 300 into CH. Okay, now just bring this D, C naught and CH here. Okay, and here we will get 300 into 1200. Okay, 36, you can say 36 and 4 zeros. So here just see d c naught by ch. So what we will do, we'll just make it the formula of eoq. So eoq was 2d c naught by ch. So here we will multiply with 2, and this is the under root. Okay, this is the under root. So here we will do the under root. Okay, so just see, this becomes the q star. Okay, this becomes the q star, and here it is going to become 7 2 1 2 3 and 4 zeros. Okay, so after solving it, you will get 848.52 units. Okay, so EOQ is going to be this one. So in the examination, you just remember the shortcut. Okay, what shortcut I'm just going to give you. See here, this 72,000, it is the product of this 600 into 1200. Okay, this see 300 into 2, it is going to become 600 into 1200, and this quantity were given. So what you have to do, you have to just do q star equals to under root of q1 into q2. Q star equals to under root of q1 into q2. When okay, only when it is given that tic at q1 is equals to tic at q2. Okay, you can use the shortcut only when, okay, you can use this shortcut that q star equals to under root of both the quantity, that is q1 was given as 600 and q2 was given as 1200. So we will directly get 848, but the condition is that it must be written in the question that tic at q1 it is equals to tic at q2. Okay, so this the statement must be written. So this shortcut you can remember. Okay, so this is all about today's lecture. In upcoming lecture also we will study more about EOQ. You can see I have written the other question, so we will solve it in the next lecture. Okay, so just don't worry, we will solve the inventory in the upcoming lecture also. Okay, so for this lecture, thank you. Okay, this lecture, thank you. Study hard and study well. Okay, so that's about today's lecture. Thank you.